The rank of a matrix is the number of non-zero rows in its reduced row echelon form. So, in the examples that we saw before, we saw that this matrix reduced to the 3 by 3 identity, so it has rank 3 because it has 3 non-zero rows. Each of the other examples we looked at has rank 2, so this is a 2 by 4 matrix, so it has only those 2 non-zero rows. This one has 3 rows, but one of them is all zeros. So if we look at its reduced row echelon form, we see there's only 2 rows that are not all zeros. And in the last one, when we row reduce it, we see that there's one row here with entries that are non-zero and another row with entries that are non-zero, and the third is all zeros, so it doesn't matter. Now, the idea of rank most becomes apparent when we look at an example maybe like this one, where it's not apparent what the rank is because we're not in reduced row echelon form yet, and something interesting happens when we row reduce it. So let's see, so if I subtract row 2 from row 3, then this is going to look like 2, negative 1, 3, 1, 0, 2, and then here I'll have 3 minus 1, 3 minus 1, and negative 1 minus 0, and 5 minus 2. And what's happened is I see a copy of the first row down here at the bottom, and that's because this third row here is actually the sum of these first 2 rows. And so if we continue to row reduce, what do we get? Well, I can do minus row 1 from row 3, so I'll subtract that out, and that converts it now to a row of zeros. So I have this guy, and I can see at this point that the number of non-zero rows in the reduced row echelon form is going to be 2, because those last 2 rows are not going to cancel out, but I'll just do the last steps anyways to take it into reduced row echelon form. So let's see. So I'm going to swap row 1 and row 2. So 1, 0, 2 is up here. And then let me do a second row operation and subtract my new row 1 2 times from my new row 2. And so 2 minus 2 is 0, and negative 1 minus 2 times 0 is still negative 1, and 3 minus 2 copies of 2 is going to be minus 1. And then I can, let's see, multiply by minus 1. So now we have obtained the reduced row echelon form of the original matrix, and we can see that there are 2 non-zero rows and 1 zero row. So the rank of this one is equal to 2. The rank is important because it tells you effectively how many equations you really had in your original system. So this one looks like a linear system maybe that was corresponding to 3 equations, but it turns out that one of those equations was sort of junk information. It was redundant because the third one was actually made up of the first and second. And so it wasn't really necessary in the end. And so the rank is telling you how many equations you kind of really have in your system once you get rid of the unnecessary junk data.